All right, welcome to 5.2. Good morning, good afternoon, good evening, good night. It's actually quite early in the morning here. Well, not quite early, 8:28 in the morning here. I'm actually out in San Bernardino, California. You can see some of the mountains out there. I'm sitting in the back seat of my car. My son's out playing in a golf tournament. It's freezing out. It's like 48 degrees. My wife's watching him play, saying I'm going to go watch him play on the back nine. So anyway, but let's get to 5.2. But yes, of course, extra credit opportunity, assignment extra credit opportunity. Tell me something interesting about San Bernardino, the city of San Bernardino, or the county. Well, we can stretch it out. I know one very interesting fact about San Bernardino County, but come up with something good, and you can earn an assignment extra credit point. How about that? So cool. All right. Yeah. All right. Let's look at 5.2. Let me share that and let's get rolling with it. So I want you to warm up, just solve those basic equations. So pause and do it, and then make sure you check, practice your checking. Okay, so obviously you got x equals -2, and then remember you plug it back in and both sides match, check, check. And then on this one, you would subtract 9, divide by 4, plug in the -2 for a into the original. And there's a reason why we're practicing our checking, especially right now. We'll get to that in a minute. Okay. And I didn't mention, by the way, that 5.2, this is the second of the 3 ways that you're going to learn how to solve linear systems of equations. You'll love this method way better than graphing. It's actually really kind of fun and pretty cool. Okay, before we get to that, let's do this one. So assign and define a variable, write and solve an equation to answer the question. The length of a garden is 2 times its width. If the length of the garden is 10.4 feet, what is its width? And one thing I don't have here is you can assume that the garden is rectangular. Okay, all right. So I set W equal to the width of the garden. So see if you can figure out how you would solve this. Okay, so that means 2W equals 10.4, right? Because if we know that the length is 2 times the width and the width is W, that means 2W is equal to 10.4. And divide by 2, and so we get 5.2 feet. Obviously, you could check that. 5.2 times 2 is equal to 10.4. Okay, try the next one. The remaining amount in an account is 490 more than the balance was 3 years ago. The current balance of the account is 5,697. What was the balance 3 years ago? Remember, always assign to find a variable. So go ahead and do this problem. Okay, so I said B to be the balance 3 years ago. And if that's the case, then the balance 3 years ago plus 499 would equal what it is now, which is the current balance of 5,697. Subtract 499, and there is your answer. And obviously this number should be less than this number, which it is. And if you added 5,198 with 499, you get 5,697. Now you may have set the balance equal to the current one, in which case you would have gone B minus 499. You know, if you, well, yeah, you'd have to actually go B equals 5,697 minus 499 if you said B to the current balance. Yeah. Okay, onward. Learning target. How you're going to learn how you can solve use substitution, to solve a system of linear equations. Did I mention it's early? Obviously, I'm having troubles reading. So this game, Zip Zap Zoop, really fun game. We actually can play this on Zoom. So take a look at the rules for it. It's pretty cool. Basically, if a number says zip, if a number is a multiple of 4, you say zip. If it's a number that contains 4, like 14, you say zap. If it's a multiple of 4 and contains 4, like 4, you say zoop. So like if we were to start this game, we would go, 1, 2, 3, and then zoop, 5, 6, 7, zip, 9, and so forth. So remind me, let's play in class. It's actually a lot of fun. So let's remind me to do that because I'll probably forget, you know me. Okay, onward. Okay, work with your imaginary partner or call a friend, and you're going to solve the system of linear equations using 2 methods. First method, we're going to solve for x first. Okay, so what we're going to do is we're going to solve for x in one of the equations. And if you want to do it the way I did, I isolated the first x. I solved for the first x, okay? Then we're going to substitute the expression for x into the other equation to find y, okay? So we're going to take what we get for x and whatever that's equal to when we isolate it. So let's actually just do it. -7 minus y, right? Because I'd subtract y. We're going to, since x is equal to that, we're going to plug -7 minus y into the other original equation. And look what happens. How many different types of variables do we have? There's 2 y's, but only one type of variable, right? So go ahead and simplify and solve for y. Distribute. Combine like terms. 5y and 1y, 6y. Boom. And boom. Now I know what y is. Y is equal to -5. Then it says substitute the value of y into one of the original equations to find x. Okay. So we could do that. Or notice how we have x isolated here, and it was just like one step. So chances are you didn't make a mistake going from this to this. You could plug in there. And it really won't matter because at the end, so we have x is -2. So what's our solution? -2 comma -5. And at the end, you're going to plug it into both to make sure it works. -2 plus -5, does that equal -7? Yes, it does. -5 times -2 is +10. Plus a -5 is 5. Does that equal 5? Yes, it does. Check, check. Okay. The other method is solve for y in one of the equations and basically go through the same thing, but first we're going to isolate y. So I did that from, looks like the second equation here. Doesn't matter. You could pick either one. So now I'm going to take that 5x plus 5, since that's equal to y, I'm going to plug it into the other equation. So see how I put in the 5x plus 5 for that y right there. One type of variable left. Easy equation to solve. Don't really need the parentheses. Combine your like terms. Subtract 5. Divide by 6. Now I have what x equals. That's -2. Plug it into where I have the y isolated. Look at that. We got the same answer, which makes sense, right? Because there's only one solution to the system. It's the same system, just 2 different ways of doing it using the same method. I don't know what the deal is with these arrows. That's weird. Anyway, awesome. And that's substitution right there. So what are the 3 steps? 1, solve one of the equations for one of the variables. In other words, isolate one of the variables. If it's 2 equations in your system that has 2 variables like x and y, pick one of the 4 variables, right? The x or the y in one of the equations, or the x or the y in the other. Find the one that's easiest. Don't make this more difficult than it needs to be, right? And then once you have that, substitute the expression from step 1 into the other equation, right? So then you only have one type of equation, one type of variable in your equation. And then once you have what that one's equal to, then plug it back in and you're done. Figure out the other one and then obviously check it. So look at this system. Okay, notice x, y, x, y. So it's a system. Do we need to even worry about isolating one of the variables? No, one's done for us, right? That y is done for us. Okay, so again, I'm going to take what y is equal to, since it's equal to it, and I'm going to plug it in for y in the other equation. Super important that you do the other equation, okay? And then we just need to simplify that. So I'm going to distribute. I'm going to combine my like terms. I'm going to subtract 45. And I'm going to divide by 16. And there we go. Oh, let's get an update on my son. He is not playing very well. Bogey on the first hole, then hit out of bounds on the second hole. He's a total mess, my wife says. Oh, well, that happens in golf sometimes. Okay. So x equals -4. Then what? Yeah, we got to figure out what y is. So we're going to plug it in where? Where's the easiest place to figure out what y is going to be if we're plugging in for x? Hopefully you said right up here, right? Because y is isolated. All we have to do is simplify that side. All right, so simplify that. And so what's our solution? Remember, it's an ordered pair. Think about this. Think about when we graphed, right? It was the equations of the lines of two equations. We're looking for where they intersect, because that point of intersection is a solution for both of the equations. So it's -4, -1. And then we're going to check it by plugging in. Go back to your originals. So doing that here on this one, it's -24 and +5. Does that equal -19? Yes, it does. And obviously, if I plugged it in to the first one here, -2 times -4 is 8. 8 minus 9 is -1. That's what y equals. All right. So why don't you guys go ahead and try the one on the left? All right, I'm back. So obviously y was isolated, so all you had to do was plug in -4x in here. For some reason, I flipped the two sides of the equation. I don't know why I did that, but anyway. Don't really need the parentheses. Get your x's together and get x equals -2, right? Then we got to figure out what y is. Where's the easiest place to figure that out? Well, kind of easy in both situations, isn't it? But probably the bottom one. Let's see what I did. 8. And so we have -2, 8. And then check it. Go back and plug it in. Plugged it into the top one. And is -6 plus 14 equal to 8? Yes, it is. Check. All right. Try the one on the right. Oh, another variable that's isolated for you. What a friendly algebra teacher you must have. All right, give it a shot. Okay, so hopefully you plugged that in, distributed, combine your like terms, isolated the term that has your variable in it by adding 28 to both sides, divide by 25, and now what? Now we've got y. We got to figure out what x is. Where's the easiest place? Yeah, right up there, right? Plug that in, and you get -1. So what's your solution? Remember, it's an ordered pair. It's a point. It's on both lines for these equations. -1, 1. Check. Plugging into this one. Boom. And boom. Check, check. Awesome. Okay. So now we're going to ramp it up a little bit. All you have to do now, though, is isolate one of the variables. And I've put in red here the variable that you should isolate if you want to do it how I did it. You don't have to. You can isolate any of the four and it would work out. But if you want, just check sure your work's the same as mine. There you have it. Okay, pause the video and give it a roll. Okay, so obviously we would add x to both sides and then plug into the other equation. Okay, same method as what we've been doing. Don't really need those parentheses, or we're distributing a +1, right? Doesn't change things. Combining like terms, subtracting 3, dividing by 4, plug in. Where's the best place to plug in? Hopefully you said right here, y equals x plus 3, right? Because the y is isolated. Y equals 2. So we think our solution is -1, 2, but we should probably check it. So let's check it using the 3x plus y equals -1. Or I guess I did it in the first one here. Checks. Okay. Now let's plug it in here too. 3 times -1 is -3, plus 2 is -3 plus 2 equal to -1. Yes, it is. Okay, try this next one. Isolate the red X. Pause the video, give it a shot. Remember, you got to practice these on your own, and then you can watch and see how you did. Now, hopefully you're checking and you know you got it right, in which case you can really kind of zip through this, right? All right, so I think you're getting a picture on this. I hope so. So if y is 0, where's the easiest place to find x? Where is it? Oh, right here, yes. Okay, so x equals -2. Right, your answer is an ordered pair. So -2 comma 0, and then check it. I'm just showing a check with 1, the top one, but really you should be checking it with both of them. -3 times -2 is +6, plus 0 is 6 plus 0 equals 6. Yes, it is. So it works for both. Check, check. Okay. All right, go ahead and try these. Same, similar type stuff here. So I'm going to kind of pause it, try it, and I'm just going to zip through these here. Again, the key, remember, is once you've isolated it from one equation, plug in to the other. Okay. So you got 2. You didn't get that, go ahead, pause the video and study it and figure out what you did wrong. Okay, now try the one on the right. Pause the video. All right, back. So hopefully you realize you can't just get -1. You have to multiply everything by -1 there, right? And we plug into the other equation. Distribute the -1, combine the like terms, subtract 1. And we got x equals 6. Remember where we're going to plug in. Right there, right? Y equals 3x minus 1. Make your life easier. Nothing said you can't plug into one of the originals. That's totally fine, but I think it's a lot easier to do that and then just check it anyway, because you're going to check it anyway. You should be. Okay, and if you plug in to the top one, 2 times 6 is 12, minus 17, does that equal to -5? Oh, you betcha. Same with the other one. If I go 3 times 6 is 18, minus 17, does that equal 1? Yes, it does. Okay, all right, let's try a couple of word problems using these. A drama club earns $1,040 from a production. Way to go, drama club. A total of 64 adult tickets and 130 student tickets are sold. An adult ticket costs twice as much as a student ticket. Makes sense, right? Usually that's the case. Try to give students a little break. Same thing usually with seniors. Okay, assigning and define variables. Write a system of linear equations that represents this situation. What is the price of each ticket? So what's unknown, what we're trying to solve for is the price of the adult ticket and price of a child's ticket, okay? Notice when you do these systems, they're usually going to give you 2 sentences that basically you're going to form 2 equations to make up your systems from the 2 sentences, one from one sentence, one from the other, okay? So let's go ahead and assign or define our variables. It doesn't really matter what you make x, but if you want to do it like I did, I'm going to set x equal the price per adult ticket in dollars, okay? So then obviously y is going to be the price per student ticket, okay? You could do it the other way around, totally fine, doesn't matter, but that's how I chose to do it. Okay, so what are we going to do here in order to figure this out? Okay, and I said 2 sentences. This one, it's actually 3. The first 2 sentences make up kind of one of the equations. So $1,040 from a production. 64 adult tickets and 132 student tickets are sold. Okay, well, think about that. Wouldn't that mean that the total money raised from selling adult tickets plus the total money raised from selling student tickets has to equal 1,040, right? Well, how would we represent the total amount of money raised from adult tickets? Wouldn't it be the number of adult tickets sold times the price? So what would that be? Wouldn't that be 64, right? Because that's the number times X. That's the price, right? And then for the student tickets, it would be the number of them, 132 times Y. And what do those have to add up to? 1,040. Okay, then the next sentence says an adult ticket costs twice as much as a student ticket. But remember, we're trying to balance it out. We're trying to make an equation. So think about it. We have the cost of an adult ticket's up here. Down here is the student ticket. How do we balance them out? Well, one way would be to multiply the smaller number by 2 since it's half as much, right? So one way would be to multiply the price of the student ticket by 2. What's another way? Hopefully you said divide the bigger one by 2. So we could have had x over 2 or 0.5x equals y. Either way, it doesn't matter. Okay, so we're using systems now. Hey, we got a variable isolated, don't we, in our system here? Nice. So all we have to do is plug in that 2y. Okay, take it from here. All right, I'm back. So hopefully you multiplied those. You combine your like terms. You divided 1,040 by 260. Hopefully you're seeing some compatible numbers there. And you get y equals 4. Well, where's the easiest place to find what x is? Yep, right there. So x is going to equal 2 times 4, which is 8. So what is that telling us? It's telling us that the price of a student ticket is $4 because that's what y is, and the price of an adult ticket is $8. Again, probably want to check it. Well, we can see real quickly, right? Isn't 4 half of 8 or 8 is double 4? So that works according to that third sentence that was up there. And then for the other, we would plug in, and it's 64 times the number of adult tickets plus 132 times the number of kids. Gets us 512 plus 528, and those obviously add up. Yay, we did it right. Okay, one more. Yeah, there's 64 total students in a math club and a yearbook club. The math club has 10 more students than the yearbook club. Of course, write a system of linear equations that represents the situation. How many students are in each club? And I know you're saying, well, I could probably do this by guessing and checking. I know that. I'm well aware of that. We're starting with easier systems that we're solving by substitution and then moving on to more difficult ones. So practice it with this easy one. Okay, what do you think M represents? Yes, the number of students in the math club. What do you think Y represents? Right. Okay, try writing your equations. Okay, and then look up here. Okay, pause it. All right, well, hopefully your two equations were M plus Y equals 64, right? Number of students in the math plus the number of students in your book equals 64. And then how about the math club has 10 more than the yearbook club? Remember, you have to write an equation. So one way would be to add 10 to the poor, or the smaller number, right? Because the yearbook club has 10 less, so add 10 to them, then they're equal to the number of math. Or you could have done M minus 10 equals Y, or Y equals M minus 10. Okay, and then you use substitution. Oh, we got a variable isolated. All right, go for it, do it. So we plugged in, combined our like terms, isolate our term that has our variable, divide by 2, plug into the other equation, and we get 37. So what does that mean? We think our correct answer is 37 math club and 27 yearbook. Does that make sense? Just think about it. Does it make sense? What's 27 plus 37? Yeah, 64. And isn't 37 10 more than 27? Yes, it is. All right. Next, exit ticket. I want you to solve this system by substitution and by graphing. So we get a little graphing practice, and we're just, again, emphasizing that it doesn't matter what method you end up using, you should get the same answer. Although graphing, remember, is difficult, can cause issues if you're not completely accurate. Okay, go ahead and do this entire problem, both ways. Okay, so the graphing, obviously they're both in y equals mx plus b form. So for the top one, probably go up to 0, 1, that's the y-intercept, and then go up 3/1, plot a point, draw your line. For the second one, it's y equals 1x plus 3. So go to 0, 3, your y-intercept, slope is 1, up 1/1. Oh, how nice. End up hitting right there, which actually was a point we plotted for both of them, which was 1, 4. So let's see if we get that by substitution. Notice how both of these are equal to y. So wouldn't that mean we would just set 3x plus 1 equal to x plus 3? In other words, one way to think of it is we could take this 3x plus 1 and just plug it in for that y. Okay, so then solve this, get your variables together, right, by subtracting x from both sides. Subtract 1, plug in, and look what we get. Good. Awesome. Hope you enjoyed this wonderful video lesson from the backseat of my car in San Bernardino. Maybe, not sure if I'll do one from this spot ever again. But anyway, hope you had a good one. And we're 2/3 of the way through the 3 methods for systems. How about that? Congratulations. All right. See you soon. Bye.